Hello everybody, good afternoon. My name is Samantha Dyer. I'm a senior here at Chapman University. The title of my presentation today is The Matchup to Find Pancreatic Cancer. I know a lot of you here have a very personal connection to pancreatic cancer, whether it be as a patient or a caregiver. Although I have no personal connection with this particular cancer, I do know what it's like to have cancer affect your life. When I was in high school, my mom was diagnosed with breast cancer, and I saw the impact it had on not only her, but our family as well. And ever since, I've been fascinated by cancer research and all the new discoveries being made. So today, my mission is to talk to you about a new study relating to pancreatic cancer and how it is detected and diagnosed in the body. But before we begin, I want to give you some background information on why pancreatic cancer is so hard to diagnose, a little bit of an overview of the immune system, and then talk about the research, its conclusions, and implications. So, as you may know, the pancreas is a small organ located behind your stomach that helps digest food and regulate blood sugar. However, the location of this organ is kind of problematic. It's very hard for doctors to examine during regular checkups. You need more intensive tests to actually see the function of the pancreas. So another problem is that pancreatic cancer patients in the early stages of pancreatic cancer often don't exhibit any symptoms, or their symptoms are so vague that they're attributed to other common illnesses like the cold or flu. So patients don't know to go get checked. These two problems make pancreatic cancer especially hard to diagnose and treat, because by the time it's found, it's usually in the late stages of disease progression, which limits treatment options. So the research I'm looking at today wants to make it easier to detect and diagnose pancreatic cancer in the body. To do this, they looked at using two important factors in your immune system, antigens and antibodies. Antigens are substances in the body that are foreign. They're not supposed to be there. But the good thing is, antibodies are substances in your body that go and find these antigens and let your body know that something is wrong. It basically kickstarts your immune system. So for our purposes today, we're going to think of the antigen as the bad guy and the antibody as the search dog. So the antigens invade your body and the search dogs go and seek out to find the antigen in your body. So now that we have this background information, we're going to talk about the research that Dr. Gerges did at UCLA. So they found that almost all pancreatic cancer tumors have a specific antigen in them called CA19-9. This antigen is used as a target to find pancreatic cancer in the body. So what they did was they designed a very specific search dog antibody that's main goal was to go in and find this antigen that is present in pancreatic cancer tumor cells. So that's all great, but how are we going to be able to know if it finds the antigen and the pancreatic cancer in your body? So what they did was they labeled the antibody. So you can think of it as like putting a GPS tracker on the dog. So this allows the researchers to see exactly where the antibody is in your body as it moves through your body. So what they did to test this was they injected mice with pancreatic cancer cells in their shoulder. This caused a tumor to grow. Once the tumor was of sufficient size, they injected the mice with the antibody they designed, and it had the GPS tracking collar on it. So what they did was then they took diagnostic scans at different time points, and what they found was that the antibody had successfully found the antigen, so the dog had found the bad guy. So on the scans, you could see exactly where the pancreatic tumor was in the mouse. So the antibody and the antigen matched up to find the pancreatic cancer. So although these results are very positive, there's a few things that need to be worked out. Obviously, they only performed this study in mice, and as you probably know, our bodies are very different from mice. So what needs to be done is we need to design an antibody that can be used in the human body, is compatible with the human body, and safe for humans to use. So this is where the research is headed, but I have high hopes that soon this method will be a viable option to detect pancreatic cancer in the body. So I know I just gave you a lot of information in a very short amount of time, but if there's anything you take away from today, these are the three things I want you to know. CA19-9, an antigen which is already present in cancer cells, can be used as a target to aid in detection. Another thing that is important from this research that this test would be the only test required to detect pancreatic cancer in the body, so no further tests would be needed. This would lower the amount of tests needed and lower medical costs for the patients and caregivers. The last thing I want you to take away is that this method has the potential to detect pancreatic cancer earlier. And early detection, as Sophia mentioned, can lead to earlier treatment, which can lead to better patient outcomes. And then before I end my talk today, I think it's important to remember that research and clinicians alike are always looking for new techniques and methods to help treat and detect not just pancreatic cancer, but all cancers in the body. And everyone can help in this fight. If you want any more information on pancreatic cancer or research relating to it, you can visit www.pancan.org, or you can contact me at samanthadyer97@gmail.com, and I'd be happy to help steer you in the right direction, answer any questions, or if you just want to comment on the presentation today. After all, we're all in this together.